Math 1108, Section 9.3, the quadratic formula. As we saw in Section 9.2, any quadratic equation can be solved by completing the square. Consequently, a formula can be derived by completing the square to solve any quadratic equation. That formula is called the quadratic formula, and we will derive it below. The derivation of the quadratic formula is the result of solving ax squared plus bx plus c equals 0 by completing the square. Okay, so the first thing we do is we subtract c from both sides. We get ax to the second plus bx equals negative c. Then we divide every term on both sides by the coefficient of x squared. That is, we divide every term on both sides by a, and we get x to the second plus b over a times x equals negative c over a. Then what we do is we create a perfect square trinomial by adding the appropriate number to x squared plus b over ax. And since this is an equation, whatever we add to the left-hand side, we must also add to the right-hand side. So if you remember, when the coefficient of x squared is 1, we take 1/2 of the coefficient of x, 1/2 times b over a, which is b over 2a. Then we square that number. So we're going to square the number b over 2a, which is b to the second over 4a to the second. And we add this number to both sides of this equation. So on the left-hand side, we'll get x to the second plus b over ax plus b to the second over 4a to the second. And we add that to the right-hand side. The right-hand side already has negative c over a, but we're going to add b to the second over 4a to the second. The left-hand side is now a perfect square trinomial. And so we can write this as a binomial squared. The binomial is x plus b over 2a, and we square that. Remember that when you factor the perfect square trinomial, this number plus b over 2a, that's the same number we got when we took 1/2 of b over 2a. So that's a useful fact to remember. On the right-hand side, in order to add the fractions, we have to have a common denominator. The least common denominator is 4a to the second. So if we multiply negative c over a by 1 in the form 4a over 4a, then we'll have common denominators. So we're going to multiply negative c over a times 1 in the form 4a over 4a, and that's added to b to the second over 4a to the second. And so in the next step, I'm going to write the binomial squared, x plus b over 2a squared. And now that we have a common denominator on the right-hand side, which is 4a to the second, I'm going to rearrange the terms in the numerator. I'm going to put the b to the second farther to the left, and then I'm going to subtract 4ac minus 4ac. Now we do what we did earlier in this chapter 9. Now we apply the square root property. So when I apply the square root property, I'll get x plus b over 2a equals positive and negative square root of b squared minus 4ac over 4a squared. And in the next step, I'll do two things at once, if that's okay. I'm going to subtract b over 2a from both sides. So I'm going to get x equals negative b over 2a. And then we have plus and minus. And then notice inside this square root, in the numerator I have b squared minus 4ac. And in the denominator, I have 4a to the second. But 4a to the second is a perfect square. So when we take the square root of 4a to the second, it's going to simplify to 2a in the denominator. And then the numerator over here is just the square root of b squared minus 4ac. Okay, so we've essentially derived the quadratic formula, but there's another perhaps more common way to write it. Instead of writing it as negative b over 2a plus and minus the square root of b squared minus 4ac over 2a, since we have a common denominator, we often see the quadratic formula written this way. X equals negative b plus and minus the square root of b squared minus 4ac, all divided by 2 times a. Okay, this is called the quadratic formula. We can use this quadratic formula to solve any quadratic equation whatsoever. We just have to make sure that the quadratic equation is in standard form. So it's written in the form ax squared plus bx plus c equals 0. And then we use the numbers a, b, and c in the formula to find the solutions for x. Okay, the number b to the second minus 4ac that's inside the square root of the quadratic formula, that number is called the discriminant. And knowing the value of the discriminant enables us to determine the types of solutions that we have. Okay, so in this part 1, if the discriminant b to the second minus 4ac is greater than 0, then that means it's positive. And we know that the square root of a positive number is a positive number, a positive real number. So if the discriminant is greater than 0, then the quadratic equation ax squared plus bx plus c equals 0 has 2 distinct real solutions, meaning that the 2 real solutions are different from each other. If the discriminant is negative, well, we know that the square root of a negative real number is not a real number. So that means that if the discriminant is less than 0, then the equation ax squared plus bx plus c equals 0 has 2 distinct non-real solutions, 2 different non-real solutions. And then the third case, if the discriminant is 0, b to the second minus 4ac is 0, then ax squared plus bx plus c equals 0 has 1 repeated real solution. And that seems to make sense if you just analyze the quadratic formula. If the number inside the square root of 0, the square root of 0 is 0. And negative b plus 0 is the same number as negative b minus 0. So you can tell by analysis that when the discriminant is 0, the quadratic equation has 1 solution, but we say that it's a repeated solution. Okay, now we'll apply the quadratic formula to a number of quadratic equations. And we'll solve them by using the quadratic formula. So on this first one, x squared minus 6x minus 1 equals 0. In this example, a is 1, b is negative 6, c is negative 1. So using the quadratic formula, then x is equal to the negative of negative 6 plus and minus the square root of the number negative 6 squared minus 4 times 1 times negative 1. And this is all divided by 2 times 1. And then we'll do some arithmetic. The negative of negative 6 is positive 6. And then we have plus and minus the square root of some number, all divided by 2. So inside the square root, the number negative 6 squared is 36. And 36 minus negative 4 is 36 plus 4. So we have the square root of 40. And we know how to simplify the square root of 40. Think of this as 6 plus and minus the square root of 4 times the square root of 10, all divided by 2. And then this is 6 plus and minus 2 times the square root of 5, all divided, square root of 10, all divided by 2. And then every term in the numerator has a common factor of 2, so we can cancel one factor of 2 from each. And so we can write the solutions as x equals 3 plus and minus the square root of 10. Okay, in the next example, 3x squared minus 7x plus 4 is 0. So in this one, a is 3, b is negative 7, c is positive 4. So we write x equals the negative of negative 7 plus and minus the square root of the number negative 7 squared minus 4 times 3 times 4, all divided by 2 times 3. And then we do some arithmetic. In the numerator, the negative of negative 7 is 7, and plus and minus the square root of the number negative 7 squared is 49. And from that, we are subtracting 4 times 3 times 4, which is 12 times 4, or 48. And then we're dividing that all by 6, because 2 times 3 is 6. And then a little bit more arithmetic. We have 7 plus and minus the square root of 1. The square root of 1 is 1, so I'll just write it as 7 plus and minus 1 divided by 6. And we can simplify further, because one solution is 7 minus 1 divided by 6, which is just 6 divided by 6, which is 1. So one of the solutions is 1. And the other solution, x equals 7 plus 1 divided by 6. This is 8 over 6. And 8 over 6 simplifies to 4/3. Okay, so the two solutions to this quadratic equation are 1 and 4/3. Okay, in the next example, in this equation, a is negative 2, b is 3, c is 1. So we apply the quadratic formula, x equals negative 3 plus and minus the square root of 3 squared minus 4 times negative 2 times 1, all divided by 2 times negative 2. Okay, then we'll do some arithmetic inside the square root. We have negative 3 plus and minus the square root of 9 minus negative 8, which is 9 plus 8, or the square root of 17. And this is all divided by negative 4. And we'll simplify a little bit more. Negative 3 divided by negative 4 is positive 3/4. And then plus and minus the square root of 17 divided by negative 4 is the same as minus plus. So we can just write plus and minus the square root of 17 over 4. And those are the two solutions. We'll do the rest of the examples in the next video.